In this video, I'm going to show you how to solve a problem like 11b. Find where the tangent to the curve y equals negative x cubed plus 2x squared plus 1 at the point where x equals negative 1 meets the curve again. So to start out, we're going to plot using our calculators y equals negative x cubed plus 2x squared plus 1. To do that, I go to y equals and I input my function, again checking it. That's negative x cubed, so negative x to the power 3 plus 2x squared plus 1. And when I plot that graph, this is what it looks like. My next step to find the tangent at that point x equals negative 1, since the question asks me to find the tangent at x equals negative 1, is to use second function in my calculator and then the program key, so I'm enabling draw. I'll use the fifth function here to figure out the tangent, and then since I want to find out that tangent at x equals negative 1, I'm going to input negative 1, which you see appear on the calculator here, and I'm going to input that, and this is what it draws. So obviously this is not the best view to see what's going on. It seems like my x cubed function is peeling away as I approach the left hand side of the screen, and then it seems like the x cubed function is getting steeper such that there should be another intersection on the right hand side. And just to see that more clearly, I'm going to use my window and edit the scale. It seems like negative 3 to about 5 would be a good range to use for my x. And then I'm not sure what my y is going to go down to, so maybe I'll just choose negative 50 and I'll leave my y max as 10. That seems okay. So let's see what happens. If this didn't work out, I could always fiddle around with the window again and see if I can get a better view of this. Okay, so I'm going to go back in and press second, draw, tangent again, number 5, and input my negative 1 to find my tangent in number negative 1. You'll need to plot this both times. And there you can see much more clearly what's going on with this function. It's inputting that tangent at x equals negative 1, and it's intersecting at negative 1, but it's also intersecting at this point further away. It looks like it's about 4, but we want to check that. So in order to find exactly where that point is, I'm going to notice that the equation for the tangent function was given at the bottom of my screen. That's y equals negative 7x plus, and then negative 3 is my b value. The reason these small decimal values are appearing at the end is that my calculator rounds, enabling me to find this function. So I have to interpret this. I look at this and I see that my equation is y is equal to negative 7x minus 3. I'm going to go back to my y equals. I'm going to input that function. So negative 7x minus 3. And I'm going to go back to graph and I'm going to draw that. I'll know I've done the right thing as it appears now in red because I'm actually drawing that function. To find the intersection points, I'm going to do the same process I've used previously, which is to hit second and then calc, and then the fifth one down, this intersect function, and I want the cursor by pressing the right to hover over roughly where those two curves intersect. So here looks about right, and I select my first curve, I select my second curve, I ask the calculator to guess, and it produces my answer for negative 31. So to go back to this problem, find where the tangent to the curve intersects with the curve again, in that 11b, your answer would be the coordinate pair for negative 31. To really get a better view of what's happening here, you could also go to zoom and press zoom out just at the end just to see what happens. I'm going to press zoom out on that point, sure. And we can see really clearly what our x cubed graph looks like. when we're zoomed out, and then what that tangent looks like. So obviously those are the only two intersection points. Further towards the left, they're peeling away from each other. Towards the right, they're peeling away from each other. And we've got two intersection points when x is -1 and also when x is 4.